Hello, welcome to Graphing in R. We're going to be doing some basic graphing, very simple plotting in R. I know you were introduced a little bit to this in Swirl, and we're going to be doing just simple basic graphs. I'm going to be walking you through how to do them step by step with the data that you've uploaded to your RStudio 2 weeks ago and the same data that you are working with running t-tests and ANOVAs and subsetting last week. So here we're going to take the same subsets of data and the same data set and just make some basic graphics. There's a lot of different graphics you can make. R is really great at displaying data sets in interesting ways. So this R script file will once again be posted for this week along with this video. I encourage you to work with my R script, copy things right over mine. Don't reinvent the wheel, so make it easy on yourself. I've also made some comments of things that are helpful for this week, things that you can try out. And along with this video, I'm also using the built-in R data sets. So you can still work along with my video and work with the built-in data sets just like I'm doing. So first notes that I want to go through to get started. Sometimes plots will continuously write over themselves. And so you're not actually building a new plot like you think you're building. You're building one plot on top of another plot. So whenever you need to do that, you can run this code here, dev.auth, and it just clears whatever plot is in your plot window down here. So it can be helpful if, for instance, sometimes when you add one legend and then you try to add a different legend, it'll just keep both of them. So you need to kind of clear all your plots to restart, and this will help you do it. Keep in mind too that question mark plot and question mark plot, you're going to need to go to the generic XY plotting in the base package. For many of you, this will just naturally come up, but I have a lot of different packages downloaded in my R. So this gives you a lot of information about basic plotting in R, along with links to other factors, graphical parameters and such. You can also do question mark par, which is for, question mark par, which is, sometimes it's overly helpful. Question mark par, and then that will open up graphical parameter help page. So this gives you some more information about different arguments that you can put in with your plot. And the last one would be question mark PCH. And these will give you the help page to adding points to a plot. So it's once again working with points in your graphics. These three question marks and help pages I think will be really helpful throughout the video. All right. So first things first, just like in Swirl, you can use the command plot and then give it your data set and you're going to get a very simple plot. So once again, working with Iris data set, we can see that it plots all of the data for Iris. So it plots sepal length versus sepal width versus sepal length, sepal width versus petal length, sepal length versus petal length. It plots all five of the known conditions. So you can see that several of these seem like they have close to linear relationships. So petal width and petal length seem like they have a linear relationship with one another. But this is kind of difficult to interpret. There's a lot of information here. We can see that for the other plot types, we get even more complicated plots, all of these different scatter plots that can be a bit difficult to interpret. The built-in dataset cars, if you remember, this is just speed versus distance. So it only has these two columns. So it doesn't give you the same plots as Iris and MT cars. It gives you one plot where it's plotting speed versus distance. So as you can see that the higher speed you go, the higher distance you go in general. We can also look at sleep and USA arrests. So these are just doing some of the basic plots. It might be helpful for you to do this with your data set to see what sort of variables seem to have a linear relationship with one another or seem to have no sort of relationship with one another. You can also do plot instead of just this X only, this one data set, you can do X and Y. So you can specify, once again, subset a column. So have this be your X and have this be your Y. So this is just a subset of the Iris data set. It's not the whole Iris data set. So we're specifying what we want on the X and what we want on the Y. Because when we run just plot, we get all five variables. But when we specify what we want our X variable to be and what we want our Y variable to be, we get one plot. So iris sepal length is our X, iris petal length is our Y. So X versus Y. But we could see maybe which ones we want to do based on this original one. So sepal length and petal length, we can see here, yeah, maybe they do have a connection. I want to look at this closer. You can call it out sepal length versus petal length, look at it closer. You can do this with many of the other data sets where they seem to have maybe a reverse linear relationship. And one thing to note is you do have to do this in the order of X versus Y. So your X is your first, your Y is your second. You can be very deliberate and put X equals and Y equals, and it'll give you the exact same plot. But based on the way R works, this has to be X, this has to be Y. It's going to plot this on your X axis, it's going to plot this on your Y axis. So for instance, if you wanted to do murder in the USA and urban pops in the USA data set, we can see that we get murder on the X axis, just like it is here, urban pop on the Y axis. But if we switch those, it switches our axes. So you have to make sure what you want to be on your Y axis and what you want to be on your X axis are properly just stated. So here's just another example, length of sepal versus petal, length of petal versus sepal. So make sure that you are putting X and then Y. One of the things that's important for these plots is as you can see, it puts everything in black and it puts everything as open circles. So you can change the color, which we're going to do later, and you can also change the type of point that it's using. As I mentioned early in the video, point is the PCH, which is adding points to a plot. We can use PCH information to change these types of points from open black circles into something else. So PCH we can specify, and there are a lot of different things that it can be. I like to use this handy little table here, where if you specify PCH to be a number 0 through 25, you're picking any of these points. So for instance, PCH 19, this should give us a closed circle, and PCH 23 should give us a grayed out diamond. So here we're looking at the same exact plot that I just showed you with the open circles, this one, but now we've closed the circles. And we can change this into the grayed out diamond. We can change this into upside down triangles, any of the different symbols specified here. You just write PCH and then equal to whatever number you want the point to be. In addition, you can also change this plot from being just a scatter plot with points into being something with lines, both lines and points, part of a line, a histogram, or a step graph. So the first one would be if we change it to S for steps. These graphs are only helpful sometimes, but I'll go ahead and show them to you. You can see that this is the same graph as above. This one where we have all these points here, we can make this into a step. So this is sometimes helpful if you have a stepwise data, but otherwise it's not particularly helpful. It can be a little bit more confusing than just the basic scatter plot, but it is available if you're changing this last argument to a S in quotations. And the legend for what these are is right above here in the comment section. So S is for stair steps. P would be for points. So this should be exactly what it was before. Yep. So this is what it's set to do as a default. So putting a P here is unnecessary, but you can do it if you would like. L should be for lines. As we can see here, L is for lines. So this should give us one with lines. And this is an example of one that you can kind of see a little trend with the line. And you can see that this gets really confusing with ones that aren't very good for line type plots. These should be, shown as scatter plots, as is obvious. This is also kind of chaotic. It looks like pretty abstract art, but not a good graph. We can also do C. I don't like this one. I never use it, but I'll show it to you anyway. We can do a plot taking out the points. So we just get, instead of this line with the points together, C is just lines with none of the connecting points. So it just takes out these data points. We can also do an overlay. both circles and lines. So it kind of pulls out the specific data points. I like the way that these look. I think it gives you a lot more information sometimes. Sometimes if you're still working with ones that shouldn't have lines added, they're not actually helpful. But if you're working with one that looks like this, I think this is a decent looking plot. We can also do, along with circles and lines, we can do just points and lines. And sometimes these can be nice for an example like this. Sometimes they aren't for an example like this. So determining on what your data look like, you can determine if you want to do lines, points, circles, what looks best for your data set. One very common thing to do for a data table that looks like this, as I'm sure you've seen, is to add a linear fit line. So how linear are these data actually? Can I say that this is a linear relationship there? And you should remember from statistics that when you're adding a linear line like this and declaring a linear relationship, you're going to get an R-squared value. So we can make this basic line plot with sepal length on the x-axis and petal length on the y-axis, very basic plot. And then we can add a linear model fit line. Similar to the AOV that we did for the ANOVA, LM, which I also introduced there, is a linear fit model. LM, linear fit model. So I want to create a linear fit model of my petal length, which is my Y, in relation to my sepal length, which is my X. And this is for my data set iris. I could also, instead of putting the data set here, I could do iris $ petal length. So either way that you want, but you have to specify which data set that you're doing. So I want to do a linear fit. This is my command of my Y in relation, remember the little squiggly, to my X for this data set. And this creates a linear fit model. I would name this fit1, something similar. So now I have linear fit information about my data set here. So how do these data compare to one another, the length versus the length? And then there's a command AB line. And AB line, you can see here that you have to have information. Well, this just says it's all null. This isn't actually very helpful. But if we look at the help page here, it adds straight lines to a plot. So this is a command to add a straight line to a plot. And you need to provide fit data. What's going on with that line? So I have my basic scatter plot. I run my linear model for my Y versus in relation to my X variables. So remember your dependent versus your independent for a data set. Then you AB line your linear fit, and then you can specify your color. I'm going to go way more into color later, so I'm going to skip over that right now. So there's a linear line that shows up, but we still don't have any R-squared information. We just have a line. And we can see that actually it looks like these data are kind of linear. Let's check their R-squared values. And we do this by doing summary of our linear fit. So summary of fit 1, we can see here our R-squared is 0.76. Our adjusted R-squared value is 0.76 pretty much. And we get our F statistic value. We get some of our standard error, our mean, our max, everything. So an R-squared of 0.76 is not particularly good. Typically you want at least above 0.9. So I would say these are close to linear, but not considered to have a very strong linear relationship. Okay, so here's another example using cars. We have speed versus distance. So speed is going to be held constant. It's our independent variable. Distance is going to be our dependent variable. And we're going to once again do a linear fit using the command LM. LM is a command for fitting linear models. We're going to do, instead of using this format before where I specified the data set, I'm going to use this subsetting with the $. So I'm going to look at this plot. I have my independent variable of speed, my dependent variable of distance. I'm going to do the relationship of my independent variable on my y-axis to my dependent variable. I'm going to do the relationship of my dependent variable on my y-axis, your dependent variables on your y-axis, to my independent variable on my x-axis. So y in relation to x, or distance in relation to speed. And I'm going to do a linear fit model of this relationship. And I'm going to put this line on my graph. I'm changing the color. Once again, I'll go over this a little bit later. And then I'm going to look at the fit. So this R squared value is 0.65. So this is even less of a strong linear fit, even though it looks like it's probably also linear. The R squared value gives you a lot more information about how close to linear these data actually are. And I like these types of graphs. A lot of people tend to add a comment here, R equals whatever, and it provides some nice information to see if you are actually getting a linear relationship in your data. Okay, so that's basic scatter plots and adding a line to scatter plots. I'm going to move on to making a histogram right now. So there are two ways you can make a histogram. You can use the plot command and change the argument at the end to an H. Before we were doing O, B, remember P is for point, S is for step. So you can change it to H, and that makes it into a histogram. This is a histogram of the IRIS data set. This is a histogram of the urban population data set, the USA arrests. And here's another histogram of USA arrests. Along with plot and H, you can also do the command hist. That also creates a histogram. These histograms, I always use hist. I think it's easier to work with. I think the histograms, it creates better bins for each of your data sets. So I like hist more, but you can choose either way that you want. Here's a histogram of the USA arrest murders column. And one thing to note is when you're running a basic hist command like this, hist, it sets your breaks to a certain number. So breaks are how many bins that you have, how many columns that you have. In the petal length here, we have 2, 4, 6, 8, 10, 12. In USA arrest here, I have 2, 4, 6, 8, 9. But I can change the amount of breaks by using the argument breaks equals and then the amount of breaks that I want. So I can change the amount of breaks here to 40 different breaks, or it's broken up into 40 different bins. I can change the amount of breaks into 5, or I can change the amount of breaks into 100. I pretty much always leave it as what it's saying, what it's basically defaulting to doing, but you are able to change the amount of breaks if you want to. Just be careful about choosing either too few, where you're manipulating your data to tell something that might not be true, or you're choosing too many and now your data aren't really explaining anything. Okay, that's basic histograms. They're pretty straightforward. We're going to look a little bit more at adding some colors and labels in just a minute, but you can also do a box and whisker plot. I really like box and whisker plots. I think they are helpful, and the command for them is box plot. So box plot, pretty intuitive, box plot and graphics here, and you'll get some information about your box plot. One thing to note is you can either provide a data set, or a lot of times you can provide a formula. So I am mostly working with a formula because those tell you valuable information. So here the formula, the first example here is just providing it with different X values. So your different values that you want to plot. Here we're going to look at iris data set for sepal length, sepal width, petal width, and there's no formula here. So you can do it this way, where you're plotting sepal length, sepal width, petal length, petal width. I'm going to look at labeling and legends a little bit later. So you're plotting the kind of range and interquartile range and mean value for each of these. So we can see that sepal length has the highest mean when compared to the other factors, right? So this graph is kind of showing you the range of the data set, the interquartile range, and then your average, your mean. You can also use a formula where we're relating sepal length in relation to sepal width. So here we're getting sepal width in relation to sepal length, because once again, you are going to be doing, I need to fix this. This is actually always going to be your your dependent variable in relation to your independent variable. So it's always going to be your y-axis in relation to your x-axis. So here we have the y-axis in relation to the x-axis, and it's plotting all of the different relationships between each of these. So we can kind of see a trend that's occurring where the averages tend to be increasing with the average sepal length tends to be increasing with the average sepal width up to a certain point, and then that relationship kind of stops here at like 3.4. So that tells you something a little bit interesting about the data. You can also do this with the CARS data set where we're looking at the y-independent or y-dependent value of speed versus distance. And here we can see that there does seem to be kind of an increasing mean. And this is showing a little more information than the scatter plot with showing some of the information about the mean and the interquartile ranges. Once again, you can either do this $ to call out your columns, or you can tell it your data set and use the column names. You're going to get the same exact graph. Box plots you can also turn sideways by doing horizontal equals to true. Once again, true needs to be all capital, and I'm not sure why it just gave me that error, but you can turn your box plot sideways. So you are, sometimes it's a little easier to look at, sometimes it's not. It's your preference and what your data set look like. But horizontal equals true flips your box plot sideways. All right, that is a basic intro to the plot types that we're expecting you to be able to make. So basic plot, basic histogram, basic box plot. Those are the commands: plot, hist, and box plot. Your data set should already be able to be subsetted, able to be picked out at columns based on last week's assignment. So you should be able to copy these exact code with your own data set, see what type of graphs look interesting, see what R values you're getting if you think you might have linear data, and be able to do a plot, a histogram, and a box plot. Labeling becomes very important because without being able to label your plot, a lot of times they aren't really telling you much valuable information. For example, what is this plot saying? There's no labeling, so we don't actually really know. So the command for adding labels, within the plot command, you're going to be adding arguments. So here we want to plot iris sepal length as our X and iris petal length as our Y. And in order to add labels, we use this argument xlab or xlab for label. And this is a label for your x-axis. Ylab is label for your y-axis. Main and sub are labels for your main title, and sub is for your sub x title. So you have to do xlab equals, and then do in parentheses where it turns green what you're going to be, what you want your label to be. So I want to label my X label as iris sepal length. Remember, these are in quotations because these are strings, these are words. I want to label my Y label with these words, and I want my main with these. So when you plot this all together, you can see that we have our X label here, we have our sub label, we have our Y label, and we have our title. So here's how we're adding labels. I've tried to comment this out for you to make it really easy. You can just copy this command, type in your own column that you want on your x-axis here, your own column that you want on your y-axis here, change to make these your own label words, and go ahead and run this command. It should work for any data sets. This is a very basic command with its arguments. We can also make labels on histograms. So instead of a plot command, we can do hist, changing the arguments is exact same. So y lab, x lab, and main, once again in parentheses. We can see that this changes the y label, x label, and title. We can also change these labels and change the amount of breaks. As I discussed earlier, we can change it and add a sub label. And I'm trying to just provide as many examples as possible so you can work with these codes and see all of the different ways to change even just, little tiny details. So once again, looking at box plots, we can look at the extra amount of sleep per each group for box plots. And if we want to add labels, once again, X label, X lab, Y lab, main lab in quotations, we can see that we're getting our title, X label, Y label. So these are just basic how to add labels. If you're starting with something like a box plot here, you can either type in X label equals X label, or you in Y label equals Y label. And then you can skip a line as long as your parentheses come with you, and do title equals title. And then as long as you're closing your quotation, you can skip another line. You can keep writing on that same line. You can skip a line and then come over, as long as your parentheses are coming with you. And you can see running just this first line of code runs until it finishes the parentheses. So don't be super concerned about, skipping lines or doing this. Sometimes it's easier where it doesn't run all the way over here where you can't see everything. So as long as this parentheses is coming with you on your next line, you can go down as much as you want. Also, I just made a mistake here. The main title is not called title, it's called main. So it still let me run this code, and it just didn't do anything. It didn't put a title here, it didn't give me an error, it just ignores it. So sometimes you got to check that your code is actually doing what you want it to do, even if it's not giving you an error and if it's letting you run it. So that's one of the nice things about the plot commands, is it gives you a lot less errors than some of the other commands. Okay, adding color. This is my favorite part. So all of the colors are available here on this website. This is a lot of colors, and some of them are really pretty. Here are all of the color names. So corn silk, blue, blanched almond. Notice these are one word. So you can choose your colors from here, what colors you want to use. I just love some of these Dodger blues. And the way that you change color, I showed this a little bit before, but you have your basic plot command, your X and your Y. And if you want to add a color, you add this argument, COL equals, color equals, COL. And then you can type in any name of any of these that you want. Dark olive green, dark orange 1 as one word, but they have to be in parentheses. These are words, these are not numbers, they're in parentheses. I'm sorry, quotations, not parentheses. Well, they are in parentheses too, but they're in quotations, as you can see here. So we can do purple. We can do cadet blue. We can do deep pink. Just making sure that you're copying the exact words that are on here. Ghost white, dark sea green 4. You can just copy and paste here if you would like, or you can type it in yourself and it'll change the color. Color equals quotation, whatever color you want it to be. When you're doing color as a basic argument like this, it's always going to change the color of your points. So if we have a plot that we have the X labeled, the Y labeled, the title labeled, the subtitle labeled, and then we add color equals deep pink, we have, oops, sorry, I only highlighted either. We have kind of a nice plot. This is all labeled. This has some nice color to it, looks pretty good. We can easily add an AB line in here. Remember before, we could add the line as I showed you earlier to kind of show that this is linear or not. Or you could do it yourself with your own data set to see how your linear fit is just by running your own LM command. So if you were to do LM of iris and the independent variable will come second, that's going to be our X. So our dependent variable is petal length in relation to our X value, which is our independent variable, which is sepal length. So we can just do a fit like this. We can see what our coefficients are. We can then we can either name this again as fit2 and then do summary of fit2 and see what the R squared value is without even adding a line. Or we can do summary of this command, that should give us the same thing. So whether you name it as a variable or not, it doesn't really matter. And then we can also add an AB line of fit to. As you see, it just added this AB line in there. This is what I went over before. I'm just kind of showing you how to do it again, reiterating the concept. And then the color I can do as Dodger blue, or I can do whatever I want. I can change it to purple. I can change it to dark olive green, whatever the colors are that you want in there. So once again, I just ran a linear fit model, looked at a summary of it, found the R squared value, not super high, but nothing too low, and added the line here. I have a nice looking graph now. I have some colors, it's all labeled. This is a great graph. You can also change the color of your title, your subtitle, your X axis, and your Y axis label. And the way that you do that is through these commands here. So color is for your basic points. Color of your axis is for your axis labels. Color of your main is for your title. Color of your sub is for your subtitle. And column of your label is for your, I thought that was for, oh, it's your Y axis and X axis labels. And the color for your axis is your actual axis numbers here. So let me make a comment about that so we can remember that. So once again, I can make as many spaces here as long as this parentheses comes with me. So my column axis, this is for numbers on the axes. And we also call these tick marks. And then this column label is for X and Y labels. This is for your title labels. And so we have here color axis, we have color for your main and subtitles, and column for your X and Y labels. We can also change the size of these points along with the shape as I showed you earlier. So PCH, this is your basic PCH, but you could also do PCH 14 or whatever you wanted to do. So for instance, if I were to add into here an argument that says PCH equals 6, it'll change the type of symbol that's being plotted. If you change it to PCH 16, once again, you're getting a different type of symbol. But along with changing that symbol, you can also change the size. And the way that we're changing size is by using a parameter for changing the plot size. So there's no help page for CEX. It's part of the graphical parameters. As I showed you before, the question mark par is going to bring you to the same page. So you can search in here through CEX. We can search here for CEX. And this is a numerical value given the number by which plotting text and symbols should be magnified. So this is saying, here's your basic default size. What sort of magnification do you want? So if you set it to be 1, this is your size. If you set it to be 2, it's going to be magnified by 2. If you set it to a value less than 1, it's going to make these smaller. So for instance, I'm going to magnify it by 4. So magnify points by 4. And so these should get bigger by 4. You can see here that they did. But I still have it as the default PEH or PCH. So if I were to do PCH equals 16 again, we can see that I'm getting these magnified big filled in circles. PCH equals 6 will be the triangles again. And we can see that CEX is just changing the magnification. And this changes the type of point, as I went over in the very beginning and then again here. So once again, if you do smaller than 1, you're going to get values that are really small. So sometimes it's nice to do them a little bit bigger or a little bit smaller, especially if you maybe don't have a lot of data points, or if you do have a lot of data points. We can also change the size of these axes. So, you know, maybe these numbers are a little too big because you have a lot of them, or they're too small because you only have a few. You can also magnify your axes by using this argument, cex.axes. So once again, we're coloring our points, our axes, our titles, and then our X and Y labels. We're magnifying our points by a factor less than 1 by 0.4. So our points are going to be smaller, but we're going to make our labels bigger by 2. So our labels, you can see here, our axis labels are bigger. We can also change not only the axis labels, but our X and Y labels, our main title, and our subtitles. So CEX label .lab is for your X and Y labels. Excuse me. And then cex.main is for your main text, cex.sub is for your subtext. So I'm going to make these 2 times bigger. They should all be double the size of this. So yep, there they go. They're now 2 times bigger. You can change these to smaller. Say you just want a big title, but you want everything else to be the same. Then you can change the title to 5 times bigger. And now you have a huge label up here. So you can see when you hit zoom that this is big. These texts are big, and maybe these are a little too big. We might want to make them smaller. Just change these CEX values here. This is for basic plotting, but it's going to be the exact same commands, cex.axis, cex.lab for the histograms. So once again, we're kind of a little bit changing the size of the labels, 1 to 1.2, CX main 1.8. I think these are pretty good sizes. I would probably work with these. But as you can see, when I do CEX equals 0.4, I don't have any points. So it's not making any of these bins smaller. If I were to do 1.4, it doesn't change the graph at all. But it doesn't give me an error. It lets me still do that, even though this CEX is for points. We can also do these with the sleep data set. So you can see that this is a box and whisker plot on a box plot, and we're changing, we're adding labels and changing the colors here. We can do these with other histograms where we're, you know, I'm just using a bunch of different colors here just to show you all the different options. We can individually labeled bins with this one here. So the way that I'm doing that is instead of doing color equals 1 color as I did here, so color equals 1 color, I do color and then I use a C command to bind these together, and then I write as many colors as I have bins. So I have 5 bins here, I need 5 colors, and I have to do them in order. So the first one's going to be dark turquoise, the second one's going to be turquoise, navy, blue, and light blue. So when I run this, yeah, we can see turquoise, turquoise, navy, blue, light blue. If I only do 4, then what it's going to do is it's going to copy dark turquoise, turquoise, navy, blue, and then it's going to go back to dark turquoise. So now the last one should be the same color as this one. Yep. So if you only give it a certain amount of labels and less than the number of bins, it's going to kind of cycle back through these. So if you wanted to alternate colors, well, then you only give it 2 colors. So take away the other 3 colors. Now it's just going to be dark turquoise, turquoise. So that's kind of hard to see, but we could do, you can see that it kind of alternates. So depending on how you're grouping your data or how you want to change things, color with the C bind command and then all the different colors that you want can be really helpful. Turquoise, I'm going to change that back. There we go. Okay, so that's how to change color of pretty much everything on the graph. And the last thing that I really would like for you to know how to do is add a legend. This is often the hardest part. This can be the most frustrating. I've linked a lot of helpful links for creating all these different types of graphs. I hope that it's really clear for you. You can just work in my code and my examples. Once again, these are all built-in data sets, so you can work with these exact code here, but legends are kind of tricky. So there are several ways of doing them, and sometimes they work and sometimes they don't. So please just don't get frustrated. You can work with it. Sometimes you might just have to do a manual legend in Excel or something, PowerPoint, and that's okay. But I would give it a fair shot in R. Okay, so legend is an argument in a lot of the commands, but it can also be a standalone command. So first I'm going to look at it as an argument. So here we have a bar plot of sleep extra, the extra hours of sleep from the sleep data set. And I'm going to have the legend is going to be the groups. So there's only 2 groups. That creates kind of an easy legend. But we can see that the legend it created was a legend for each of these individual bar plot points. We haven't really been working with bar plots because I don't like them, and you don't need to know how to do them. But this is more just to illustrate something about the legend. So even if we were to do just a regular plot of sleep extra, it doesn't allow me to do legend as a parameter here. So you can see like legend is not a parameter. You have to do it differently. So this is only for things like bar plots that I'm really doing these for. But in order to do the legend here, you can't just type legend equals the column with groups. You have to do the command levels. So if we look at levels, so first let's look at sleep group. We can see that there are 2 levels and they're 1 or 2. If we look at mtcars, MPG, we can see that they don't give me a levels command. But if I did levels, mtcars, MPG, it tells me no. So these are numerical, we can't get levels from it. But if we do iris species, then we can get, once again, levels here. So, and if I type in levels, iris species, we can see what levels are there available. So levels is for a command that's more of like a group or a species or a factor or like a variable name, and it's not for a list of numbers. So levels, for instance, if you're looking at the United States and you're looking at deaths per each state, well, the numbers of deaths don't have levels, but the states have levels. They have 50 levels because there's 50 states. So levels is kind of your grouping or how many groups there are. And the levels command tells you what those groups are. So we want our legend to be the amount of levels in sleep group. So there's only 2 levels in sleep group. We want that to be our legend. So we can see that instead of graphing the legend for every single bar plot, it's now only graphing these 2 levels. And we can change the color of all of these, once again using color and then the cbind, and then using however many colors as there are levels. We can also have legend as a secondary command. So once again, using this original plot here, if we want to add a legend, we want to look at how to add a legend by doing $legend. We can add this as a separate command. So it's not an argument inside of the like plot command, bar plot command, but it's a separate additional command. So here we have bar plot, we in the parentheses, we plot that, and then we want to add a legend. So the first thing that you have to do is add X and Y coordinates of where to position the legend, but I never do this. I always use the position name. I thought it went, so they're right here where it's bottom right, bottom, bottom left, left, top top right, right center. So I do top left or top right most of the time. And remember, these are words, so these are in parentheses. Then I do my legend is going to be, I want to make a legend in the top left, and I want the legend to be of the levels that are available there. And I want to have them coordinate with color, and I want the point of the legend to be 15. I'm going to go over why you have to do PCH equals 15 in a second. So here, my legend is in the top left. If I change this to be top right, it changes where the legend is. But as I told you at the beginning, sometimes plots just write over themselves. So I'm need to run that command dev off here to clear this, and then run a new one, a new plot, and then a new legend. If you change this, sorry, I added a period there. If I change it to the bottom or bottom right, it just keeps adding a new legend, and it's not actually refreshing a new plot because I'm not calling a new plot, I'm just calling a new legend. So I do dev off, and then I call a brand new plot, and then I can create a legend wherever I want. So bottom left, I'll just keep it there. I want my legends to be the amount of levels in this group, and I want them to be the same colors as the color points. So I'm telling my bar plot to make the bars this color. I'm telling my legend to make the points this color. But I have to do PCH 15 to tell it what sort of points I want to make. If you don't tell it what sort of points you want to make, it just doesn't make points. As you, oh, shoot, I just ran my whole code. I apologize. So if I make this plot and then I make this legend in the bottom right, you can see that there's no points here. It doesn't know what points to make it. So you have to tell it PCH, and then pretty much always 15 is going to be this little square. If you're working with different points, sometimes you can change your PCH, but 15 is this little square. It's typically the most helpful. All right. We can also change this bar plot, or I'm sorry, we can also change the legend to be horizontal by doing horizontal equals true. We can make we can change the number of columns by doing in col. So if we do this in the top right, so you can see it, we can see that it looks the same as being horizontal, but I really just told it I want to have 2 columns. And we can also give it a title by doing the command title equals and then the words that we want the title to be. So change a legend to horizontal, change a legend to 2 columns, add a legend title. Those are all the different things we can do in a legend in a basic bar plot. Once again, you don't super know how to do a bar plot, but I wanted to use this as an example for how to make a legend. So along with bar plot, we can do the same thing for other types of plots. So this basic plot with an X column, a Y column, and then we want colors. We can do this command just like this. So I used a plot X and Y, and I want colors to be factor of iris species. So factor iris species is going to be the same as levels iris species. So the number of factors or the number of levels is just how many groups are there. So if I did this exact same code and I did levels, it gives me an error. So for some reason, I have to run it with factor. I don't really know why. I think it might just be part of this data set, but sometimes levels will also work. We can also do levels iris species, and you can see there's 3 levels. So we could also do this plot and just using the same method as before, we could do red, green, blue, make our own 3 levels, close our parentheses again, and run it like that. So instead of having this color, I want to do the amount of colors of the factor here. We can also just do it on our own by calling out the amount of colors that we have as the amount of factors. This gets a little confusing. I'm not expecting you to be very good at factoring out the amount of levels in your data or changing the color that way. This is a simple way, changing the color to 3 colors. This is straightforward. For those of you who have a lot of factors, sometimes it's easier to do it this way. So if we look at adding this plot here, adding a legend in the top right, and we want our legend to be the amount of levels in iris species. We want our colors to be 3 different colors. We can either do 1 through 3, or we can do name what those colors are. We want our PCH to be 1. So PCH of 1 would be an open circle, and we want the title of our legend to be iris species. So if we add this legend here, we can see that the title is iris species. PCH of 1 is these open circles. If we were to change a PCH to 6, it would be the upside down triangles. 16 or 15 would be the little square blocks that we used before. Typically, you want to try to match your PCH of your legend with the PCH of your plot. So for instance, if I were to run this now with a PCH of 15, you can see that now my legend and my points match each other. I can also do the exact same thing with color. Here I said I want the color to be any color between 1 and 3, but you can also do Dodger blue, hot pink, and olive green, whatever colors you like. Oh, olive green isn't a color, it must be dark olive green. There we go. But these colors now in my legend don't match the colors in my plot. So you have to make sure that the colors in your legend match the colors in your plot. So in order for that to happen, I needed to have made these red, green, and blue to match these colors that I told it to plot up here. So red, green, and blue, red, green, and blue. And then I also want my PCH to match whatever my PCH is. Okay. Every time that you're rerunning your plot too, and you're calling a new plot, it's getting rid of your legend. But every time you're running the command legend, it is not getting rid of your other legends. So it's just rewriting them on top of each other, as you can see. Okay, I'm gonna do dev off, clear all of that away. I know legends are kind of complicated. I would really mess around with these examples, look at the extra things online, and try to get at least one simple legend. Okay, once again, you can use bottom right, bottom, bottom left, left, top right, right, and center, all as one word to dictate where you're gonna go. So if you, for instance, if we had our iris width as our X, our iris sepal length as our Y, and then we made the color something like red or Dodger blue, we get this nice graph here. We can add a legend in the top right, and the legend is going to be the levels of iris species. And we want PCH1 because that's the basic PCH, and we want colors 1 through 3. But actually, we want to change these to match each other. So right now I have this as my basic scatter plot. My legend is giving me more information than that. So I have now separated my legend out to include the different species, the different factors of species, but I haven't asked for that in my plot. So the example I was doing before had showed that I had already separated out the colors in my plot, and then I separated out the colors and the factors in my legend. This example, I didn't separate out anything in my basic call for a plot, but then I tried to in my legend, and now they're not matching. So my colors aren't matching, and my information isn't matching. So therefore, I need to do my colors to match. So either I need to do colors 1 through 3 and see, not in parentheses because those are not words, colors 1 through 3. Okay, so I get black, red, and green, and then colors 1 through 3 in my legend. Oh, I went too far. So black, red, and green, colors in my legend, black, red, and green. That's 1 through 3. I can also do colors C, blue, navy, and green. So I have blue, navy, and green now, but I need to make these colors the exact same as the colors in my legend. So blue, navy, and green. And then if I want to change the PCH to something like X's, I need to change the PCH in my legend as well. So now my legend and my data match. If you want to change colors, if you want to change PCH, you need to change it in both your plot and your legend. All right. There's an even more complicated way of changing your colors. That's my actually preferred way, but it takes a little practice to get used to. So when we look at the iris data set, we can look at this iris data set here. We've been working with it for 3 weeks now, and you can see sepal width and length, petal width and length, and then the species. So we can actually add another column here for color, and we add color based on whatever group we want it to be. So here I'm gonna say I want to have a column called iris color. We don't currently have a column called iris color. It doesn't exist. When I type in iris and I look at all the options, it's not an option, but I want to make it. And the way that I do it is by saying, I want to make this column, iris color, and I want to have it be for this group, the iris species of Setosa. This, you have to do double equal sign. So I want iris species is assigned to Setosa to be my iris color column, and I want this column to be magenta. So you have to use double equal signs for is exactly, and then you have to do your color. Once again, it's a word, you have to do your color in quotations. So I want to make a new column called iris color. I want this column for all of the iris species that are exactly Setosa, and I want that column to say magenta. So now if I run this and I look at iris color, oh, did you see that? Look, now I have a factor that comes up here. And if I run that, I can see that for the first set of iris information, I now have the word magenta, just like I assigned here. If I look at the overall iris data set, look, I have a new column over here. I have a new column called color, and I have magenta for all of the species that have Setosa. Then I do the same thing for all of the species that have versicolor. I want to make those cyan, and all of the species that are virginica, I want to make yellow. So now I'm adding to those I'm adding to that column. If I look at the iris data set now, I have a full column here filled out with colors. So now when I look at iris color, I have a full column here that I've added to a data set. And now when I plot an X value versus a Y value, I can just use this column. I want my color to be my color column. Your color column has to be some of these colors. It has to be a valid color. You have to name them in quotations, and you have to name them as a valid color. But now you can just use them as, I want my color, my color of my points to be based on this column. I want my PCH to be whatever you want, and I want my magnification to be 2 times. So now look how beautiful of a graph this is. And once again, you can add the column title, you can change all of these. And now if we add a legend to the top right, I want the legend to be, I'm just going to tell it what I want the legend to be. So here, instead of using levels of iris species, I'm just going to say, I want it to be Setosa, versicolor, and virginica. Then I'm going to say, I want the color to be, once again, I'm going to name exactly what these are, magenta, cyan, and yellow. And I want the PCH to be whatever the PCH was that I used before. I didn't use the same PCH here. Here I use PCH 16, here I use PCH 6. So I want the legend to be the one that I want it to be. I could also do a legend. I'm going to show you in the top left so you can see. If I did a legend of levels, iris species, and I did colors of iris color, and I did the same PCH, it would give me, oh, it doesn't like that. Iris color. Oh, I got to do levels. It doesn't like that. Let me see. Maybe if I try factor. There we go. Sometimes it needs factor and sometimes it needs levels, but that's not even the right. So I guess in the plot, you can use color equals iris color, but in the legend, you have to name what those colors are. So we have to stick with this format here. Even though I think maybe there is something that I'm doing wrong, but I don't want to spend time trying to figure it out in the video. All right, so showing you again, if we look at sleep data and we have extra sleep hours of sleep, your group and your ID, we want to add a new column called color. We want sleep with a column called color. We want to add it to any group where it is exactly equal to 1. So all of group 1 is going to get hot pink, and all of group 2 is going to get green. So all of group 1 is going to get, all of group 1 will get pink, and all of group 2 will get green. Then if we see what sleep looks like now, we can see that we have a whole new color column here, sleep color, and we have a whole new color column here. As a note, you can add a new column for whatever you want. You just tell it what you want it to name, you tell it how you want it to be grouped, and you tell it what information you want to have in it. So if you wanted to add a whole column that says, 0, or if you wanted to add a whole column that says, something, you just add a column exactly like this. So now, once again, we can plot our sleep extra data with the colors from our sleep color new column. PCH is 6. We're going to magnify by 2. We can see that we're getting these upside down triangles at a bigger CEX, and the PCH of these upside down triangles. And our sleep is based on this column. So now if we do our legend in the top left, and we're going to do our legend is going to say group 1 and group 2. Our colors are going to be hot green, hot pink and green, and our PCH is going to be the same. We can see that we get a nice looking legend that matches the group, the plot. We can also do title equals group, so you can kind of say what your legend is going to be telling you. All right, we're pretty much done. This is, if you want to put your graph in log scale, all you have to do is put log and then say what axis you want in log scale. It's really easy. You can just copy this here. You can export your plot by this, export. Save as image, save as PDF. Save as image gives you the option to do a PNG, a JPEG, a TIFF. Those are the 3 I would use. You can maintain your aspect ratios, or you can tell it the height and weight that you want. You can update your preview based on these height and weights. So if you want, or height and width. So you can change it, update your preview, and here's where you name it, and here's where you say where you're going to save it. So really straightforward. You can also export as a PDF, how big you want your PDF, portrait or landscape, and then where you want to save it and what you want to name it. If you want more information about exploratory data analysis, there is a Swirl course that you can do here. There's several links on this week's Canvas page that help you in graphing. I've also tried to comment a lot of different information with different plotting functions, helpful tips. I've tried to comment the code with as much helpful information as possible. So hopefully you can follow along with this video, work with the built-in data sets, then try it with your own data. Once again, you can always use help. You can email me. You can use Google. If you want to clear anything, as a reminder, you can use these little broomsticks to clear everything away. And I believe that is all for this week. So I hope you have a great rest of your week, and I look forward to seeing your graphs. Thanks.